Hello Year 8 and welcome to a very special Science with Mrs. Smith. Yay! So what we're going to do today is to revise the metals and non-metal elements topic. So what do you need to know? This is a really quick 5-minute video because I expect you to be supplementing this with knowledge from BBC Bitesize, which should be in the video description below. So first thing you need to know, let's get my periodic table here. So metals are the big part of the periodic table. They are all the ones on the left of the periodic table, starting with our really reactive group 1 here, alkali metals, and moving over to our less reactive transition metals here. Non-metals are all on the right of the periodic table. And again, we've got our really reactive fluorine, which is one of the halogens or salt makers. And then we've got some of the slightly less reactive ones as well. Noble gases, of course, are completely unreactive. And how do they react? Well, we've said with the alkali metals. So unsurprisingly, metals are going to react with oxygen or water to make a base. Okay, and a base is something which neutralizes an acid, which is what is made when the non-metals react. Okay, so when our non-metals are reacting with water or hydrogen or even oxygen, they are going to make an acid. And when they react, and when the metals react with oxygen or water, they are going to make a base or an alkali. An alkali is just a soluble base, but so it's just one type of base. There are lots of types of bases. You've got metals, you've got metal oxides, you've got metal carbonates. Most of these are not soluble. And then you've got your metal hydroxides, most of which are soluble and are therefore alkalis. Okay, I don't think you really need to know that much about the difference between alkalis and bases, but we'll just cover it there to, cover all bases. So, next thing, reactivity and displacement. I've already said that our group 1 are super reactive. Group 2 are also pretty reactive. And our transition metals, not reactive. Reactivity is all about how big and bossy and pushy they are at this point. Okay, so if you've got a big, bossy, pushy, say for example, rubidium, yeah, that's going to be able to push any less reactive metal, which is most of them, out of the way during a reaction. So for example, if you had iron oxide and wanted to get rid of it because, for example, you don't want your things to go up your bike to be rusty, you could use a more reactive metal such as magnesium and just put the two of them together. And the magnesium, because it's bigger and bossier and more reactive than the iron, which is over here, so the magnesium will push the iron out the way and say, I'm stealing the oxygen, you go away. Okay, so you get a nice, lovely, shiny iron metal bike again. And the magnesium is that white, powdery, dangerous because it's corrosive, magnesium oxide. Reactivity is literally just how much it is going to react. So if you're very reactive, you're going to push everything out the way so you can react. And if you're not very reactive, like gold or platinum or silver, you're going to let yourself be pushed away because actually you're kind of happy on your own and you don't want to hang out with like the oxides and the chlorides and whatnot. You just want to be on your own. So there's 2 ways of extracting metals. Some of them, gold, platinum, silver, these are all found native. They don't want to react, they don't want to do anything, they just lie around waiting to be found. But the more reactive metals, so for example iron or sodium, they are going to be found separately. They're going to be found in ores, and we have to get them out of their ores. And most of this topic has been about how to get things out of their ores. And there's 2 main ways of doing that. One of which is displacement reactions, like smelting. So for those of you that like Minecraft, you put the iron ore in, you put the coal in, which is mostly carbon. Carbon is more reactive than iron, and so they swap places. The carbon says, go away iron, I'm stealing the oxygen, and you end up with iron and carbon dioxide. So when you're writing the equations, you would always write down the most reactive one first, and then you write down oxide, usually. I mean, if it's a chloride, you'd write down chloride, but you'd swap the partner to the most reactive one, and then you would write down the less reactive one on its own. So what else do we have to do? We have to also know that we can separate metals by electrolysis, and we did this last lesson where we put our electrodes into our copper sulfate solution, and we had copper covering our negative electrode. Problem is though, we needed to do loads of steps before we could do the electrolysis, and running that amount of electricity is really expensive. So that's why the most reactive metals are expensive. We can't displace them, and we do need to use electrolysis, which is expensive. We can also extract copper a few other ways. So to be green, if we've got a low grade ore, which is too expensive to get copper out of, we can use plants or bacteria to absorb all of that copper, and the bacteria then kind of poo it out. That's not the correct term, but they put it out into a leachate, and they just poo it out, and you can then gather the copper from that solution. Or with the plant, they absorb it all, so when you burn the plant to make energy, you're then left with a load of copper ash behind, and that's really quite useful. Okay, we need to see about neutralizing acids, so we're going to do an experiment now. So do you want to pause the video and we can get... All right then, everybody. So Theodore has very kindly agreed to help us with the next part, because you need to know how to neutralize an acid. So there are 3 different ways of neutralizing an acid. One of them is you can do acid and metal. Acid and metal is going to make salt and hydrogen. And again, naming salts, it's all linked to the BBC Bitesize. So it's not difficult. You only need to know 3. Hydrochloric acid makes a chloride, sulfuric acid makes a sulfate, and nitric acid makes a nitrate. Okay, so this is why it's really important when you're out walking and you get stung by a nettle, which is acidic, you can rub some metal over it like a key, and that will neutralise the sting. Second way to do it, acid and alkali makes salt and water. And the third way to do it is the one that Dory's going to do, and that is acid and carbonate makes salt, water and carbon dioxide. Okay, Dory, so we're going to pour our acid into our carbonate, which is all pre-prepared. Pour it in. We are making salt, water, and these bubbles coming up are carbon dioxide. And there you go, beautiful volcano. Thank you very much, Dory. Okay, so for the rest of your revision, you've got BBC Bitesize, you've got your books, you've got other YouTube videos. I'm not going to pretend that other videos don't exist. They're not just not as awesome as mine. So take care, Year 8, and I will see you ready for your test tomorrow. Bye.